Hey there guys, so up to here we've seen how to differentiate, we've seen how to use the derivative to find the gradient of a curve at a given point. Here we're going to take it a little bit further and use differentiation to enable us to find the equation of the tangent to a curve and what's called the normal to a curve. So before we get into the maths, let's have a look at the definitions. So hopefully we've all seen tangents before. We found equations of tangents to circles in the coordinate geometry chapter. So a tangent is a straight line that touches a curve at a given point and has the same gradient as the curve at that point. Now a normal is nothing too scary. A normal is simply a straight line that's perpendicular to a curve at a given point. So if we find the equation of a tangent, we can then find the equation of the normal quite easily, because the normal is perpendicular to the tangent. So, for example, if we have just some function y equals f of x here our blue line is tangent to the curve, so it only touches the curve at this given point. And the normal is the red line here. It's perpendicular to the tangent at this point, so it's perpendicular to the curve at this point. Now that's quite a nice little set method of working out equations of tangents and normals. So let's take a peek at that. Okay, the first thing we need to remember then is that when two lines are perpendicular, they meet at right angles and their gradients multiplied together to give us -1. So that means that the gradient of the tangent times the gradient of the normal is equal to -1. Now I like to use this shorthand notation here. M, remember, in y equals mx plus c is the gradient. So I like to use m with a little t, gradient of tangent, and m with a little n for gradient of the normal. So mt times mn is equal to -1. Now from that we can divide by the gradient of the tangent, and that tells us that the gradient of the normal is -1 divided by the gradient of the tangent. Very important, definitely a very big stepping stone that we're going to be using in every question. Okay, next up, just a cheeky little reminder on the equation of a straight line. Y equals mx plus c. We need to know that m is the gradient and c is the y-intercept. So we're going to be using this guy a lot too. Okay, now to tangents and normals. Okay, so when it comes to finding normals and tangents, we start in exactly the same way. So the first step is to differentiate the function. This gives us our gradient function. Now you can obviously use notation dy by dx, or here, just to save time, I've gone for y dashed of x. The second step is to then substitute the x coordinate of the point that we are interested in into the gradient function. What that then tells us is the gradient of the curve at that point. So this is when we split. If we are looking for the equation of a tangent, we now that we have that gradient, remember the gradient of a curve is the gradient of the tangent at that point. So we substitute the gradient of the curve and the values of x and y at that point into y equals mx plus c to find the value of c. if we're looking for a normal, there's a tiny bit more work to do. We have to, first of all, once we've got the gradient of the curve, we then need to work out the gradient of the normal. So I've called that here mn. So remember, the gradient of the normal is -1 divided by the gradient of the tangent, or the gradient of the curve. Same thing. So once we have the gradient of our normal, it's then the same job as with tangents. We substitute the gradient and the x and y coordinates of the point into y equals mx plus c to find the value of the constant. So that's the game plan. We're going to do one example here, quite a simple example, and then in the next video we will do many more, which will be linked down below in the description. Okay, so for this example then we're using the function y equals x squared, and the point we are interested in is 2, 4. For part A we want to find the tangent, for part B we want to find the normal. So, for part A, the first step is to differentiate. So if y equals x squared, then our derivative y dashed of x is equal to 2x. So that's our gradient function. Now we can work out the gradient of y equals x squared when x is equal to 2. So gradient of curve is equal to 2 times 2, which is 4. So that also gives us the gradient of the tangent at this point. So I'm going to say, I'm just going to call it m tangent. So the gradient of the tangent is 4. So now we substitute that into y equals mx plus c. So if we put the gradient in, y equals 4x plus c. Now we need to find the value of c. So to do that, we substitute in our x and y coordinates. So remember, our point has coordinates 2, 4. So if we substitute those in, we're going to get 4 is equal to 4 times 2 plus c. Now 4 times 2 is 8, so we've got 4 equals 8 plus c. So if we take away the 8, we get c equals minus 4. So the tangent is y equals 4x minus 4. So that's the equation of our tangent to y equals x squared at the point P with coordinates 2, 4. Okay, now for part B, we're going to find the normal. So, well, we know that the gradient function y dash of x is 2x. And we know the gradient of the curve at point P is equal to 4. So now we want to work out the gradient of the normal. So remember, the gradient of the normal, so mn, times the gradient of the tangent is equal to minus 1. Now the gradient of the tangent is the same as the gradient of the curve at the point. So we know gradient of the normal times 4 is equal to minus 1. So if we divide by 4, we get the gradient of the normal is minus 1/4. So we've got the gradient of our normal now. Put that into y equals mx plus c. So we get y is minus 1/4 x plus c. Now we need to find the value of c. To do that, we substitute in the coordinates of our point, which are 2, 4. So y is 4 and x is 2. So we get 4 is equal to minus 1/4 times 2 plus c. So we get 4 is, well, minus 1/4 times 2 is minus 1/2. So if we then add the 1/2, we get c is equal to 4.5 or 9/2. So the equation of our normal is y equals minus 1/4 x plus 9/2. Good times. Okay guys, that's it for this video then. See you in the next one where we're going to do more examples and they're going to get trickier too. Take care.